A pleasant day to everyone. Today we'll be dealing with the topic arithmetic sequences and series. By the way, this presentation is from the www.mathmedical.org. Let us first differentiate sequences and series. Sequences are listed with commas while series are indicated sum. Samples are, for sequences we have 3, 8, 13, 18. Then for series we have 3 plus 18 plus 13 plus 18. Arithmetic sequences. An arithmetic sequence is defined as a sequence in which there is a common difference between consecutive terms. Okay, let's take a look on this. Which of the following sequences are arithmetic? Identify the common difference. So suppose that we have negative 3, negative 1, 1, 3, 5, 7, 9, and so on. So negative 1 minus negative 3 is equal to 2. 1 minus negative 1 is also equal to 2. Then 3 minus 1 is 2. 5 minus 3 is also 2. 7 minus 5 is 2. 9 minus 7 is also 2. Meaning, this is an example of an arithmetic sequence with a common difference of 2. Another example, 15.5, 14, 12.5, 11, 9.5, and 8. As we can see, 14 minus 15.5 is negative 1.5. 12.5 minus 14 is negative 1.5. Then 8 minus 9.5 is also 1.5. So yes, this is an arithmetic sequence with the common difference of negative 1.5. How about 84, 80, 74, 66, 56, and 44? 80 minus 84 is 4, negative 4. 74 minus 80 is negative 6. They are not common, so this is not an example of arithmetic sequence. How about negative 8, 6, negative 4, 2, 0? Negative 8 or 6 minus negative 8 is 14. And then negative 4 minus 6 is negative 10. So they are not common, so this is not an example of arithmetic sequence. How about negative 50, negative 44, negative 38, negative 32, negative 26, and so on? Negative 44 minus negative 50 is 6. Negative 38 minus negative 44 is also 6. Negative 32 minus negative 38 is equal to 6. And negative 26 minus negative 32 is also equal to 6. So the answer here is yes. It is an example of arithmetic sequence with a common difference of 6. So that is how we can identify whether the given sequence is an arithmetic or not. We just have to look into whether the two consecutive numbers do have the common difference. Any two consecutive numbers with common difference. The common difference is always the difference between any term and the term that precedes that term. So, suppose that we have negative 26, negative 21, negative 16, negative 11, negative 6. It is an arithmetic sequence with a common difference of 5. The general form of an arithmetic sequence, the first term is a sub 1, second term is a sub 2, which is equal to a sub 1 plus d. The third term is a sub 3, which is equal to a sub 1 plus twice the common difference. The fourth term is a sub 4, which is also equal to a sub 1 plus 3 times the common difference. And then the fifth term is a sub 5, which is also equal to a sub 1 plus 4 times the common difference. As you can see, there is a pattern here. So, we may say that the nth term is equal to a sub n, which is also equal to a sub 1 plus the quantity of n minus 1 times the common difference. So that is our formula in finding the nth term of an arithmetic sequence, where a sub n is the nth term, a sub 1 is the first term, n is the term number, and d is the common difference. Meaning, if we know any three of these variables, we ought to be able to find the other one unknown variable. So we just need three known variables for us to get the other unknown variable. Suppose that we have 79, 75, 71, 67, 63. This is an arithmetic sequence with a common difference of negative 4. And we are asked to find the 32 or 32nd term, or a sub 32. So we identify our known variables. So we have a sub 1, which is 79, our first term. The common difference is negative 4. And the n term, or the n, is equal to 32 because we are looking for the 32nd term. By applying the formula, we solve for a sub n equals a sub 1 plus the quantity of n minus 1 times the common difference. And then by substitution, we'll be having a sub 32, since n is equal to 32, equals a sub 1, which is 79, our first term, plus the quantity of 32, which is n minus 1, times the common difference, which is negative 4. Simplifying it, we will have 32 minus 1, which is 31, times negative 4 is equal to 124, negative 124, plus 79 is equal to negative 45, meaning the 32nd term of the arithmetic sequence is negative 45. Okay, suppose that we have the same given and we are asked to find what term number is negative 169. So we identify our given, our first term is 79, our d or common difference is negative 4, so and our a sub n is equal to negative 169, since we are looking for n. So in this problem, a sub n is 169, but we have to look for n. By applying the formula, so a sub n is equal to a sub 1 plus the quantity of n minus 1 times d. By substitution, we will have negative 169 equals a sub 1, which is 79, times plus the quantity of n minus 1, n is unknown, times the common difference of negative 4. We simplify it further, so we will have negative 4 times n is negative 4n, and then negative 1 times negative 4 is equal to positive 4. And then positive 4 plus 79 is equal to 83. And then we move 83 from right to left, so 83 will become negative 83. Remaining at the right would be negative 4n. And then you add negative 83 and negative 169 divided by negative 4. So the answer is positive 63. So n is equal to 63, meaning negative 169 is the 63rd term of the arithmetic sequence, of this arithmetic sequence. But what if the given values are like this? A sub 10 is equal to 3.25 and a sub 12 is equal to 4.25. And you are asked to solve for the first term. So let us understand the problem. What is the real question here? You are asked to solve for the difference, because as you solve for the difference, you can now find the value of the first term. So we identify. Suppose that a sub 10 is our first term. So if a sub 10 is our first term, then a sub 12 is our third term. Because from 10, we have 10, 11, 12. So if a sub 10 is equal to a sub 1, then a sub 12 is equal to 1, 2, 3. A sub 12 is a sub 3. And then n is equal to 3 since we already have 3 terms from 1 to 3. And then we solve for the common difference. By substitution, we will have 4.25 equals 3.25 plus n, which is 3 minus 1 times the common difference. So, by simplifying it further, d is equal to 0.5. Since negative 1 times d is negative d, then 3 minus 1 is equal to 2 times d is 2d. And then we transpose 3.25 from right to left, or we apply the addition property of equation. So we add negative 3.5 at both sides of the equation. So you will have 1 here, because 4.25 minus 3.25 equals 1. 1 is equal to 2d. And then to eliminate the numerical coefficient of d, which is 2, you divide the whole equation by 2 and apply the division property of equation. So d now is equal to 1 over 2, or 1/2, or 0.5. And so, if a sub 10 is equal to 3.25, since we already have the value of the common difference, we can now solve for a sub 1 using the original position of our given terms. So, by solving, we apply the formula. We substitute all the values. So, a sub n is 3.25, a sub 1 is the unknown variable, then n is 10 minus 1 times the common difference of 0.5. And then by doing some algebraic manipulation here, a sub 1 is equal to 1.25. There are actually problems like this that you cannot solve directly to what is asked in the problem. Sometimes you just really have to solve first the values that you needed for you to be able to solve what is really asked. So in this case, the question is to solve for a sub 1, but before you can solve for a sub 1, you have to find first the common difference for you to complete the given values in solving for a sub 1. So a sub 1 is equal to negative 1.25. Arithmetic series. So we are already done with the sequence, arithmetic sequence. This time, let's have the arithmetic series. Write the first 3 terms and the last 2 terms of the following arithmetic series. Suppose that we have the summation of the quantity 73 minus 2p as p goes from 1 to 50, meaning the value of p here is from 1 to 50. 1, 2, 3, 4 up to 50. So for you to get all the terms in this arithmetic series, in this arithmetic sequence, you have to substitute numbers 1 to 50 to this expression 73 minus 2p. So our first term would be 73 minus 2 times 1. So 73 minus 2, which is 71. That is our first term. And our second term, we substitute 2 here. So 2 times 2 is 4. 73 minus 4 is equal to 69. So that is how we can get the terms. So we have 71 plus 69 plus 67 plus and so on. The last 2 terms are negative 25 and negative 27. So as you continue substituting values from 1 to 50 here, you will get this series. The question now is, what is the sum of this series? How can we get the sum without clicking into the calculator one by one from 71 to negative 27? Okay. So we have this series written from first to last. So take note, the first term is 71 and the last term is negative 27. So we write it from first to last. And then we have this another series written from last to first term. So the last term is negative 27 and the first term is 21, parallel to the first series, which was written from first to last. And then what we are going to do is to add 71 plus negative 27 is 44. 69 plus negative 25 is 44. Then we have negative 27 plus 71 is also 44. Negative 25 plus 69 is also 24. As you can see in the pattern, all the sums will be equal to 44. And how many pairs do we have? So we have how many pairs? We have 50 pairs here. And then 50 pairs of 71 plus negative 27, which is equal to 44. So 50 times 44. Since we have 50 terms here, 50 terms from 1 to 50. And then, to get the sum, you will have 50 times 44 divided by 2 is equal to 1,100. So that is the sum of the first 50 terms. In general, for you not to be under that kind of process, the addition, or you arrange the series from lowest to highest and from highest to lowest, this is the general form. A sub 1 plus the quantity of A sub 1 plus D plus the quantity of A sub 1 plus 2D. So this is the first term, second term, third term, and so on until you reach the last term, which is A sub 1 plus the quantity of N minus 1 times the common difference. And then this is written in from last to first. So we add it down. So you will have this sum. This is the sum of these two parallel series. And then simplifying this, as you simplify this, S now, or sum, is equal to N times the quantity of A sub 1 plus A sub N all over 2. So this is now our general formula in solving for the sum of the arithmetic sequence, in solving for the sum of the terms in the arithmetic sequence. So S stands for sum, N is the number of terms, A sub 1 is the first term, A sub N is the last term. Okay, let us have an example. Find the sum of the terms of this arithmetic series. Summation of the quantity negative 29 plus 3k as k goes from 1 to 35. So the formula, S is equal to N times the quantity of A sub 1 plus A sub N all over 2. So we know that N here is 35. So N is 35. And the first term is negative 26. How? How do we get negative 26? We substitute 1 here to k. So you will have 3 times 1 is equal to 3. Negative 29 plus 3 is equal to negative 26. And to get the value of A sub 35, we substitute 35 here at k. So 3 times 35 is equal to 105. Negative 29 plus 105 is equal to 76. So a sub 35 is equal to 76. So the given values are already complete. We can now solve for S, or for the sum of the terms in the arithmetic series. So by substitution, we will have n, which is 35, times the quantity of negative 26 plus 76 all over 2. So you will have 35 times negative 26 plus 76 is equal to how many? 50. So 50 times 35 is equal to 35 times 5 is 5 carry 2, and then 15, 1, 7, 50. So 1,750 divided by 2 is equal to 875. So the sum of the terms of the arithmetic series is equal to 875. So do not just always remember this general formula. S is equal to n times the quantity a sub 1 plus a sub n all over 2, because you will be using this in solving for the sum. Okay. Find the sum of the terms of this arithmetic series. 151 plus 147 plus 143 plus 139 plus and so on up to negative 5. So you write the formula. S is equal to n times the quantity of a sub 1 plus a sub n all over 2. But the question is, what term is negative 5? That is what we are looking for. What term is negative 5? Because we need that. So to solve for that, we'll be moving back to the formula. A sub n equals a sub 1 plus the quantity of n minus 1 times the common difference. So here we have negative 5, which is our a sub n, because we are looking for n of negative 5. What term is negative 5? Then a sub 1 is 151 plus n minus 1, which is unknown, times negative 4, which is the common difference. 147 minus 151 is negative 4. That is the common difference. And then simplifying it further by doing some algebraic manipulation in this equation, you will get an answer of n equals 40. So now, we already have n equals 40. So we can now proceed to solving S. So n equals 40, a sub 1 is 151, a sub 40 is equal to negative 5. So using the formula, S equals 40 times 151 plus negative 5 all over 2. And by simplifying this, you will get 2,920. So the sum of the term of this arithmetic series is 2,920. So alternate formula for the sum of an arithmetic series. So this is the alternate formula for it. So substitute a sub n equals a sub 1 plus n minus 1 times the common difference. So you will have S is equal to n times the quantity of 2a sub 1 plus n minus 1 times the common difference all over 2. So we may use this if the given value is the common difference, or we do not know what term is the last term of the series. So common difference is easier to solve, because you just have to subtract the two consecutive terms of the series. So n again is the number of terms, a is still the first term, and d is the common difference. So suppose that we have this problem. So summation of the quantity 2.25 plus 0.75j, as j goes from 0 to 36. So we can easily solve for the first term here, because the first term is j equals 0. So 0.75 times 0 is 0, plus 2.25 is 2.25. So that's our first term. But the 36th term here, the 36th term is a little bit harder. So you will have this series 2.25 plus 3 plus 3.75 plus 4.5. But it is not convenient to find the last term. This one, the last term. So we use the alternate formula in solving for the sum, since we can already solve for the common difference, and the common difference is 3 minus 2.25 is equal to 0.75. So this is 3.75, not 3.72. This is 3.75. Then by substitution, we will be having all these values. N is 37, since we started with 0. So 0 is the first term, and we end with 36. So as you substitute 36, the answer would be the 37th term. So a sub 1 is equal to 2.25 and d is equal to 0.75. So by substitution using the alternate formula for getting the sum, you will have 37 times 2 times a sub 1 plus 37 minus 1 times 0.75 all over 2. And then simplifying it further, you will have 582.75 as the sum of this series. Now your turn. You can pause this video if you want to solve the following. If not, you want to know the answer already, just go on. The summation of the quantity negative 45 plus 5i as I goes from 1 to 35. So using the traditional or the first formula in solving for S is equal to n times the quantity of a sub 1 plus a sub n all over 2, since we already know that n is 35 because we start with 1 here and end at 35. First term is negative 40, since as you substitute 1 here, 5 times 1 is 5, and then negative 45 plus 5 is equal to negative 40. And then a sub n is equal to 130, since 35 times 5 is equal to 5 carry 2. So you will have 175 minus 45 is equal to 130. So that is a sub n. And then by substitution, you will get this. And then simplifying it further, the sum is equal to 1,575. What if we would want to use our another formula? So we need to have our common difference. We need to get the first two terms. So the first term is already negative 40. Let's solve for the second term, where I is equal to 2. So 5 times 2 is 10. So negative 45 plus 10 is equal to negative 45 plus 10 is equal to negative 35. So we have negative 40, the negative 35. Negative 35 minus negative 40 is positive 5, which is the common difference. So we substitute all these values into the formula, and simplifying it, you will have 1,575, which are exactly the same with the sum that we get earlier. Meaning, no matter what formula you'll be using, either this one or the alternate one, you will still arrive at the same answer. The only thing is that using this alternate formula, you don't need to get the a sub n. You just need to have your common difference. Okay, an introduction. So, an arithmetic sequence, you add to get the next term, while for geometric sequence, By the way, a geometric sequence will be discussing that in the next video. You multiply to get the next term. That's the difference. If it is an arithmetic sequence, to get the next term, you just add. And then in geometric sequence, to get the next term, you just multiply. So, arithmetic series, sum of terms. Geometric series, sum of terms also. Okay, find the next four terms of -9, -2, and 5 in the arithmetic sequence. So, you will have -9, -2 minus -9 is equal to 5 minus -2 equals 7. So, we subtract the two consecutive terms. -2 minus 9 is 7. 5 minus -2 is also 7. So the common difference is 7. So that is what we add to get the next term. So the next four terms are 12, 19, 26, 33 because 5 plus 7 is 12. 12 plus 7 is 19. 19 plus 7 is 26. And 26 plus 7 is 33. So that's it. You already get the next four terms of the arithmetic sequence. How about this problem? Find the next four terms of 0, 7, and 14. First, let us solve for the common difference. 7 minus 0 is 7. 14 minus 7 is 7 also. So the common difference is 7. You just add 7. So you will have 14 plus 7 is 21. 21 plus 7 is 28. 28 plus 7 is 35. Then 35 plus 7 is 42. Find the next four terms of this arithmetic sequence. X, 2x, and 3x. So first, you find the common difference. 2x minus x is what? Is equal to 1x or x. Then 3x minus 2x is equal to x also. So the common difference is x. So you just add x into 3x to get the next term. So you will have 3x plus x is 4x plus x is 5x, then 6x and 7x. How about this one? Find the next four terms of 5k, -k, -7k. So find the common difference. -k minus 5k is equal to -6k. -7k minus k minus -k is -6k also. So that is our common difference. You just add -6k, -7k plus -6k is -13k plus -6k is -19k plus -6k is -25k plus -6k which is -32k. So these are the universal vocabulary of sequences. The a sub 1, which is the first term, a sub n term, n is the number of terms, n sub n is the sum of n terms, d is the common difference, n term of arithmetic sequence, that is the formula, sum of n terms of arithmetic sequences, that is the formula, and we also have the alternate one if you want to use the common difference. Now, given an arithmetic sequence with a sub 15 is 38 and b is equal to -3, the common difference find a sub 1. How can we solve for that? So take note that a sub 1 is the first term, a sub n is the n term, n is the number of terms, s sub n is sum of n terms, and d is the common difference. So let's take a look from the given problem. What are the known variables? So, since we are looking for a sub 1, let a sub 1 be equal to x. And then n is equal to 15 since a sub 15 is equal to 38. So, n is equal to 15. So, a sub n is 38. And then we do not need s sub n because we are only looking for a sub 1. The common difference is -3 from the given. So, using the formula a sub 1 equals a sub n equals a sub 1 plus the quantity of n minus 1 times the common difference, we can already solve for a sub 1. So by substitution, we will have 38 equals x plus the quantity of 15 minus 1 times negative 3. So you will have 15 minus 1 is 14 times negative 3, and then you transpose it from left to right, so you will have x equals 80. And then, next problem, find s of 63 of negative 19 minus 13, or negative 19, negative 13, negative 7, and so on. So again, we identify our known back variables. So our first term is negative 19. We are looking for a sub n, so we code it as double question mark. Then a sub n is 63, since we are looking for the 63rd, the sum of the 63 terms, the first 63 terms. Then n sub n is x, since that is what we are looking for. And the common difference, negative 13 minus negative 19 is equal to 6. So what do we do now? A sub n is equal to a sub 1 plus n minus 1 times d, because we need to have a sub n for us to solve for s sub n. So we solve for a sub n, our code is double question mark. So double question mark now is equal to negative 19 plus 63 minus 1 times 6. Simplifying it, the double question mark is 353. So a sub n is equal to 353. And then, using the formula s sub n is equal to n over 2 times a sub n plus a sub n, we substitute the values. So s sub 63 is equal to 63 over 2 times the quantity of negative 19 plus 353. Simplifying it further, you will have the sum of the first 63 terms, which is equal to 10,521. Try this one. Find a sub 16 if a sub 1 equals 1.5 and b equals 0.5. If you want to try, you just post this video. But if you want to know the answer already, just continue. So we identify our known variables. Our first term is a sub 1, which is 1.5. We are looking for a sub n. Okay, so we are looking for a sub 16, where n is equal to 16. We do not need s sub n, so that's not applicable for this problem. And the common difference is 0.5. So using this formula, we substitute all the known variables to solve for a sub 16. So a sub 16 is equal to 9. What if we have this problem? Find n if a sub n is equal to 633, a sub 1 equals 9, and d equals 24. So again, we identify our known variable. First term is 9. A sub n is equal to 633, and then n is x since we are solving for x, and the common difference is 24. So this is the formula that we need. By substitution, you will have this, then solve for x. The value of x will be 27. So meaning 633 is the 27th term of the arithmetic sequence. Find d if a sub 1 equals negative 6 and a sub 29 equals 20. So what we are looking for here is the common difference. Again, we identify the known variables. Our first term is negative 6. A sub n is 20. So n is 29. And d is what we are solving for. Using the formula, we substitute the known variables. And then, simplifying it, you will have 26 equals 28x. And then solve for x by division, applying the division property of equation. So x is 13 over 14. That is the common difference. How about if we have this problem? Find the two arithmetic means between negative 4 and 5. these two arithmetic means, meaning the two terms in between negative 4 and 5. So what are those? So we have negative 4 blank blank 5. What are those numbers? So again, we identify our variables. So our first term is negative 4 and our n term is 5. So n is equal to 4 since we have 4 terms. 1, 2, 3, 4. Okay? And then we do not need the sum of the n terms, but we need to have the common difference x for us to determine the two arithmetic means between negative 4 and 5. So by applying the formula, we substitute the known variables. By simplifying this, you will have x equals 3. So we add 3, negative 4 plus 3 is equal to negative 1. Negative 1 plus 3 is equal to 2. Then 2 plus 3 is 5. So the two arithmetic means are negative 1 and 2 because it forms an arithmetic sequence. Find three arithmetic means between 1 and 4. So we identify our known variables. So you will have our first term which is 1, our n term which is 4, a sub n is 4, then n is 5 since we have 5 terms here. So you will have 1, 2, 3, 4, 5. So we do not need s sub n and we have to solve for the common difference. By applying the formula a sub n equals a sub 1 plus n minus 1 times b, we substitute. So you have 4 equals 1 plus the quantity of 5 minus 1 times x. Simplifying it, you will have x equals 3/4. And what is 3/4? In decimal, that is 0.75. So you add 1 plus 0.75 is 1.75. 1.75 plus 0.75 is 2.5. 2.5 plus 0.75 is 3.25 plus 0.75 is 4. So in fraction, the three arithmetic means are 7/4, 10/4, and 13/4, or that is equivalent to 1.75, 2.25, and 3.25. Find n for the series in which a sub 1 equals 5, d equals 3, and s sub n is equal to 440. So we are looking for n here. So we identify our known variables. The first term is 5. Our a sub n is y since we do not know our a sub n. And n is also unknown here. So let's name it, or let n be equal to x. Then we are we do have s sub n which is 440 and the common difference of 3. So in here we have two variables x and y to solve. Let us first solve for a sub n equals a sub 1 plus the quantity of n minus 1 times d, or this is equal to y. So y is equal to 5 plus the quantity of x minus 1 times 3. So there is y since a sub n is equal to y. So you will have, so we stop here. We stop here solving since we already have two variables, an equation with two variables here. So let's stop here. For the meantime, let's move on to another formula, which is the formula in solving for the sum of the terms. So n sub n is equal to n over 2 times a sub 1 plus a sub n. Then by substitution, you will have 440 equals x over 2 since n is equal to x times 5 plus 1. So we do have another equation here. So take note that y here is equal to 5 plus the quantity of x minus 3. So we already have the value of y here. What are we going to do with the value of y here is to substitute it in here. So we will be having, we change the value of y to 5 plus x minus 3 times 1. So there you go, 5 plus the quantity of x minus 1 times 3. So In this case, we already have an equation in one variable which is x. So we solve for x. We simplify it. So you will have 440 equals x times 7 plus 3x all over 2. And as you can see, if we multiply x and 3x, we'll be having a quadratic equation. So you will have to apply your learning in factoring or in solving the quadratic equation, the roots or the solution of the quadratic equation. So you will have 880 equals x times quantity 7 plus 3x. We eliminate 2 by multiplying the whole equation by 2. So you will have this quadratic equation 0 equals 3x squared plus 7x minus 880. You solve for x and get the positive 1. So x is equal to 16. So one of the solutions of that quadratic equation is 16, the positive 1. So you get that, and that is the value of x. If you have any more questions with regards to what we discussed today, please feel free to send me a message using our group chats. Thank you and God bless.